last section of chapter 2 is 2.5. So let's take a look here. We're at the right lesson 2.5 and scrolling down to question number 2. In number 2, it says to first write the converse of each statement, and then is the conditional statement true? So here's my conditional statement, so I need to decide if that statement is true. And then once I rewrite that and write the converse, is the converse also true? So let's begin with the conditional statement. If a triangle has 3 congruent sides, then the triangle is an equilateral triangle. So yes, that is definitely true. A definition of an equilateral triangle. And when I rewrite this to write the converse, I want to take the hypothesis, that's the beginning statement, and the conclusion, and I want to switch those around. So, if a triangle is an equilateral triangle, then the triangle has 3 congruent sides. Number 4, if a figure is a rectangle, then it has 4 sides. Well, we know that that is true. We know every rectangle does have 4 sides. The converse would be if a figure has 4 sides, then the figure is a rectangle. Now, I'm going to say that that is a false statement. Here's a figure that has 4 sides, but it is not a rectangle. And here's another figure that has 4 sides. It is not a rectangle. And number 6. So we've been given a diagram, and what we know from the diagram is that we have a transversal, and we have 2 lines that cut through this transversal, but we don't know if those 2 lines are parallel. We have to decide if they are parallel to each other. That's the question. Are those 2 lines parallel to each other? So let's take a look at what's given. We know the measure of angle 1 is 7x minus 12. This angle right here is 7x minus 12 degrees. Measure of angle 3 is 6x plus 4 degrees. And the measure of angle 8 is 5x degrees. Now, in order to decide if these lines are parallel, we need to know a relationship between one of these 4 angles, one of these 4 angles right here, and one of these 4 angles down here, for example. If I knew the measure of angle 1, and I knew the measure of angle 8, because those are same side exterior angles, they should be supplementary. And if they are supplementary, then I can say, without a doubt, that line P and Q are parallel to each other. So the first thing I need to do is to solve for x. So I need an equation right now that can help me solve for x. 1 and angle 3 are vertical angles, and vertical angles are congruent to each other, I can start out by saying that 6x plus 4 must be equal to 7x minus 12. And then I'm going to solve for x. So now that I have solved for x, I can take 16 and I can replace it everywhere I see the value of x. So let's start with 7x minus 12. And let's replace x with 16. So I notice that the measure of angle 1 is 100 degrees, the measure of angle 8 is 80 degrees. Because those two angles add to 180, they are supplementary, and therefore I can say yes. Line P is parallel to line Q. And the reason is because angle 1 and angle 8 are supplementary. So because I do have same side, that should be same side exterior angles, same side exterior angles that are indeed supplementary do form parallel lines. So in number 8, I'm given this figure and I'm trying to prove that segment AB, let's highlight that, segment AB is parallel to segment DE. So what I notice is that I have two lines, and I can extend those two lines. And those two lines are cut by a transversal. If I can show that these two angles are supplementary to each other, because they are same side interior angles, then I can say that those two segments are parallel to each other. So the question is, does 142 and 38 add up to 180? So yes, these two segments are parallel to each other because these two angles are supplementary, forming same side interior angles.